right, my friends, let's take a look. To add these two fractions together, I'm hoping that it makes sense that you would need to get common denominator. So the step that a lot of people, once you get good at this, a lot of people start skipping is where they show the part where you multiply by a creative version of 1. And that's the step that I think at this point it's probably a good idea to add it back in if you've along the way stopped showing it. So the first fraction we're going to multiply by x minus 3 over itself, hence a creative version of 1. And then the second fraction we'll multiply by x plus 2 over itself. Whoops, hence a creative version of 1. Okay, and then from there, let's kind of just follow our fraction nose here. Let's distribute the negative 1 in. We'd have the opposite of x plus 3. And then let's distribute the 2 in. And so we'd have 2x plus 4. And I hope it makes sense. The whole point was to get common denominator, which at this point would be the quantity x plus 2 multiplied by the quantity x minus 3. Okay, one more step. Let's combine like terms there on the top. So let's see, combine the x's, we'd have a single x, and then combine the 1's, we'd have 7 of them. And then we've got that over x plus 2 times x minus 3. There we go. Okay, so I'm hoping that you're comfortable with that process known as adding fractions, because we're going to lean on it pretty hard to kind of like undo this adding process. So now a lot of people think, well, if you're unadding, aren't you subtracting? And not really. Anyway, so not in this case. So let's get to it here. We'll turn this into example 1. The directions for example 1 could be find the partial fraction decomposition of each rational function. But short for all that is unadd. No, I don't mean subtract. I mean find the partial fraction decomposition for each given rational function. Anyway, but we're just going to say unadd there. What I'm going to do for part A is I'm going to recycle. So I'm going to write the answer down that we had got in the warm-up. So that's the answer that we got, right? And then actually one thing I am going to do to the answer that we have there is I'm going to go ahead and multiply that denominator out. So x plus 2 times x minus 3, what would that be? X squared minus x minus 6. So typically this is the look of the problems that you'll be given where nothing's been factored yet. And it's a nice, rational function. It's not two fractions being added together. It's just a single little rational function. Now, when they say unadd, I just want to make sure we look back at the warm-up. Basically, what we're looking for is what were the fractions that were being added to get this to be the answer. So I hope it makes sense that what we got, what we started out with in the warm-up, that should be the answer when we're all done. So now let's talk about a procedure for how to get the answer. Okay, and I'm going to break this into steps as we go, and then you're welcome to kind of like write the words that go along with the steps. So step 1, my friends, in partial fraction decomposition is to factor the denominator as far as you can, preferably to linear factors, as far as you can, as long as you're using rational numbers. So, okay, so let's do that. There we go. And always, like if you've in the past had issues with factoring, then really take your time on that first step, because boy, oh boy, is it horrible to not to factor it correctly in the first step and then go through all the work and realize that you had the factoring incorrect in step 1. Okay. All right. So once you factor the denominator, the next thing you're going to do is you're going to write what's called the form of the decomposition. So let's go down here. And so the form of the decomposition is going to be basically two fractions added together where you take the factors that you see here and they become the denominators. So x plus 2 is one of the denominators and x minus 3 is the other one. Now, as far as the constants that go on top, we just happen to know that they're going to end up being -1 and 2, but that's not the kind of thing that I personally would pull out of a hat if I look at x plus 7 on the top. So what we do is we put like a capital A and a capital B there to represent these constants that we know go there, but we just don't know what they are yet. Okay, and this is what's called the form of the decomposition. And it is an important step to not skip. Okay, now the next thing that we're going to do, and this is part of the reason that I started you out with that warm-up of adding fractions, the next thing we're going to do is add these fractions together. I know it sounds counterproductive, but it isn't. It's important. So what we're going to do is we're going to say, okay, well, if you have a over x plus 2 and you need to add it to b over x minus 3, well, you'd have to get common denominators. So you'd have to multiply your first fraction by this version of 1, and you'd have to multiply your second fraction by this version of 1. All right, stay with me, stay with me. And then you follow your algebra no's. You distribute. So you'd have ax minus 3a plus bx plus 2b. And it would be all over x plus 2 times x minus 3. All right, hope you're doing okay so far, even if you have no idea where we're going with this. All right, now let me explain to you where we're going with this. I'm going to bring this original fraction down and write it to the left of my last line of work here. So I'm going to just say, okay, well, this is supposed to equal x plus 7 over x squared minus x minus 6. And I want you to notice something. I already have won half the battle. I've won the denominator battle. I made the denominators match. And so I hope it makes sense that at this point, in order for the fractions to equal each other, I just have to win the next battle. I just have to make the numerators match. So for that reason, what you're going to see me do in my next step is you're going to see me just write the numerators down. X plus 7 would have to equal ax minus 3a plus bx plus 2b. And this is how I am going to solve the mystery as to what the a and the b values are. So follow me, stick with me. The next thing we're going to do is group the x terms together and factor the x out. So you'd have the quantity a plus b times x, and I notice I factored the x out on the right side, but hopefully it makes sense that that is equivalent to ax plus bx. And then I'm going to factor the non-x terms. These would be our constant terms. I'm going to just actually not factor them, but group them together. So like this. So I hope it makes sense. What I have here is equivalent to what I had in the line above. And it's supposed to equal x plus 7. And something that we don't normally write, but I'm going to make a point of it, is on the left we have 1x. And now, what do we know? Well, we know that if these two equations are going to equal each other, then the number of x's on the right side should equal the number of x's on the left side. So that means a plus b should equal 1. And the constant term on the right side, negative 3a plus 2b, should equal the constant term on the left side, 7. And now you can see why this is in the system of equations section, because you're always going to come down to this point where you have to solve a system of equations using whatever method makes the most sense to you, substitution or elimination. You can do pretty much what you want. So I'm going to go ahead and multiply row 1 by 3. And then I'm going to add that to row 2. And then notice what I get. I get 0 A's, which was why I did that. And then I get 5 B's, and it should equal 10. And what does that mean about B? It means B is number 2. And now that I know what B is, I could back substitute into either equation. I like equation 1 for its simplicity there. And so I'm just going to put 2 in for the B, and it would say A plus 2 has to equal 1. I'm going to subtract 2 over, and it says A would equal negative 1. So now procedurally, once you've solved your system of equations and you know what your constants are, you're going to take your constants and you are going to back substitute them into your form. So I know that A is -1 and B is 2. And what would my form read if I put those things in? If I replaced A with -1 and B with 2? Well, guess what? It would say what we knew the answer was anyway. So my conclusion at this point would be, therefore, the fraction x plus 7 over x squared minus x minus 6 came from adding -1 over x plus 2 plus 2 over x minus 3. Fraction decomposed, aka unadded. All right, so I'm going to do a quick review of the steps, and then I'm going to give you a part B and kind of butt out and see how far you can get, and then we'll go through it together in the next video, okay? Step 1, my friends, is factor the denominator down as far as you can, as long as you're using rational numbers. Step 2 is write the form of the decomposition. Step 3 is add your fractions back together. Step 4 is make sure you have the same denominator that you started out with. Step 5 is then set the numerators to equal each other. Then step 6 is group the right side in order, kind of in descending power of x. Then you set up a system of equations, solve for your constants. Your next step is back substitute into your form, and you have your answer. Oh, man. Here we go. Let's see if you can write the partial fraction decomposition for this rational function. See how it goes. Check in with me in the next video. Good luck.